All right. Just back to introduction again. So in this workshop, what I'd want to do is go over kind of the Donkey software, Donkey hardware. I got some questions from the last workshop just regarding the different software packages, the different software pieces. So I tried to put a bit more detail on that for folks. And then also how that works in the simulator. So how do we move from the hardware piece to the simulator? So I talk a little bit about, there's something called a Donkey Gym part, which is what is used instead of the real camera. And that's basically how it injects the simulator instead of the real hardware. So let's get started. And yeah, just as Alex mentioned as well, please feel free to ask your questions as we go along, and you know, or in the chat as well, and we'll try to cover them as we go along. All right, so here's my agenda. Talked about we had our welcome introductions. Thanks, Alex, for that background. The Donkey car hardware and software. I want to give an overview of that. I think one of the key aspects as well is collecting training data and how to drive your Donkey car. That can get a bit tricky. People say, well, how do I use my gamepad? How to use my joystick? So I go into a little bit of detail on that. And then going into training your Donkey car. So what are the steps? It's actually quite, it's a workflow that you need to kind of understand the different steps. And then there's a whole optimization piece, which I don't really go into. I talk a little bit about the utilities that are available to see why your car is behaving the way it is. But that's a whole, that's a whole other topic. I think even, even with our group here, preparing for the virtual race, we're getting frustrated with some of the behavioral cloning stuff we're doing, and now we're trying to see, since none of us are good drivers, we're trying to see if reinforcement learning might be a better path. But yeah, so those are things for sure that just a huge topic that can just, we can go over in future, as people gain expertise, we can share that knowledge. And then I also talk about the software simulator. Okay, just a slide here about the group that's hosting this. We're really 3 groups, well 4 I guess, if Detroit is both Detroit. There's also the Ann Arbor group there, and Alex is at Ferndale. I can't remember what the
I'm in
actual location.
Troy, and I very much work in automotive. So if anybody needs a flavor of what automotive industry is doing and how this stuff relates, I can tell you that the job that I currently have is an electronics engineer at Broza, where we build systems such as power windows, power tailgates, and if any of you have a car where you kick under the bumper and the trunk opens on its own, we're the global leader in that. And this stuff that I've learned through this community has gotten me the job. And I've been now I'm starting my own group globally in machine learning, and the stuff that enables me to do this is this. So that's kind of a short of, yes, this very much does relate to the real world. Some of the things are going to change, but they do. And I strongly believe that, well, actually it totally does. Like my family, they're all software developers, and a lot of them are data scientists and database managers. All these skills are applicable.
Great. Thanks, Alex. Yeah, so really there's Detroit Automotive Autonomous Vehicle Group, and then as well us in Ottawa. And then Reiner is also on from the Stuttgart Connected Autonomous Driving. So, I guess us as a group have really kind of come together. Alex is kind of the key person that's met Reiner from Stuttgart and Nick from Ottawa, and we're kind of do a lot of, we're trying to do activities together and really build a community. All right, just before I really get into details, I just wanted to give some credits and references. You know, I really can't say enough about Ton. Jack was mentioning that. He's been such a huge contributor to this community. You know, I remember the stuff he was putting out when I was looking at it last year, and he just continually adds to it. A lot of the stuff that I've put together here is just kind of consolidated from the information that's out there. And it's my understanding of it. So, you know, if people, there seems to be a lot of people here that are also knowledgeable. If there's things that are incorrect, please let me know. So Ton built the simulator. He also built the, which he called the self-driving sandbox, the SD sandbox. He also built the Jim Donkey car, which is a wrapper around that, which allows you to create and reset the environment so you can do reinforcement learning. As well, Ed Murphy, I think Ed's on as well. He wrote this Donkey car overview, which I found very useful. And he's also one of the maintainers of the Donkey car repository. And then the Donkey car community as a whole, you know, I referenced the Donkey car docs, so it's lots of information in there.
Paul, may you allow me to say a big thank you to Ed, because he was the one who really took our idea to Ton and in the end made it really happen, and that's awesome. So a big thank you to Ed for making that possible.
Well, you're really welcome. I thank you guys for actually initiating.
Oh, hi, Ed.
Project. Hey. Then, you know, once you guys got me activated and I got Ton activated, then you just sort of get out of Ton's way.
Just make this a little bit more fun. Can you summarize the story of meeting in a parking lot in like 3 words? What was it, 2 years ago? 2?
Yes, 2 years ago.
Yeah, so basically Rainer and I met in a parking lot in Germany. Well, I was 2.5 hours late to a meetup, which was like 250 miles away from where I was. And he was still there, but luckily Autobahns let you go as fast as you can. So I made it just in time, just before Rainer left. And since then, we've actually organized several events, including some in Bay Area and virtual stuff and other events as well. And so it was actually, it's kind of cool to see all this come together. And yeah, then we ended up meeting Ed, which was really cool. And yeah, again, thank you, Ed, for helping out with all of this. But a lot of this is just kind of came together in a natural way, which is pretty cool.
Yeah, it is cool. It's cool how the community comes together. All right, so those are credits, references. Now I'll get into the Donkey car stuff. I'll start with the hardware. So the Donkey car hardware, really you start with a 1/16 or 1/10 scale RC car. Well, I think one of the critical aspects people ask, you know, can I just use any RC car? I think the key thing is that you have a separate receiver and ESC, or electronic speed control. The reason for that is we're plugging into the ESC to feed it the throttle information, the PWM signal. When you have an integrated receiver in ESC, that's one unit, and you don't have access to the ESC itself. So that's one thing. I mean, I guess if you're more electronic capable, you could take out that and put in your own motor driver as well. But really, I think the hardware that they recommend is a 1/16 scale with the separate receiver and ESC. In the diagram here, I'm highlighting the pieces that are added to it. So you can see the base there. The orange platform on top is a 3D printed base, and then we're adding a Raspberry Pi, or in I guess nowadays it seems like people are using the Jetson Nano just for the extra computing power. On just above that's the camera. And then behind that is the PCA 9685 board, which will take an I2C kind of input signal and then output the required PWM that's being requested. This is just a different view. I'm trying to highlight the connections. So the communications between the computing board and the PCA 9685 is I2C. That's just a low-level serial protocol. From there, it goes to channel 0 and 1. And I have here throttle and steering. Another issue people will get is mixing up channel 0 and 1. So it's just when you're calibrating or when you're testing the signals, you have to figure out which channel is stuck to which of those. And obviously, it won't work at all if you've got them backwards. But you can either switch them through the hardware, switching the wires, or you can also switch them in the hardware configuration. For the camera, you can have the camera serial interface, which is usually what we use for the Pi camera. Or as well, you can have a USB camera. The difference between the two is the frame rates that you can get. The CSI has a much faster pipe to the computer, so you can get a much higher bandwidth, faster images. But for our application, I think we're doing it at 20 frames a second. I don't think it really matters which we use. My call out there about the hardware configuration, it's defined in myconfig.py, so a lot of the hardware and what hardware you have is defined in there. And I'll talk about that too in subsequent slides. Oh, it's the next slide. Okay. I thought it was a bit further. So in here, myconfig.py, like this is, like you'll be visiting this file all the time. It's how you configure the behavior of your donkey car. In this context, it's how you configure the hardware. So I've called out specific pieces here. The camera type is PiCam, but in the comments there, you can see, you could put webcam or CV cam, V4L, I guess if you're in Linux, you have video for Linux, and other. I've never tried a mock camera, but there's other camera types there. The next one here, the steering and the throttle. I had mentioned the channel, so this is exactly where you define that channel. You can have, I had steering on channel 1, throttle on channel 0, but you can flip those as well. And then the values here, the PWM values, this is also kind of a trip up for new people. This is something you do when you calibrate. So the starting points here would work, I think, if you had the standard, the hardware model. But if you don't, then you can start tweaking these numbers, and you have to determine, I guess, where the limits are. So basically, what you're doing here is 460, and I'm not sure where the numbers really come from. I guess it's the timing. Normally a PWM pulse is between 1 millisecond and 2 milliseconds. So somehow this number is converting to a pulse somewhere around 1 millisecond, I guess, for the lower end here. And then for the 460, it's up near 2 milliseconds. And so you just have to fool around with those values to get the limits. Normally you can tell when you're at the limit, your servo will chatter or just start making humming noises. So I just increase it until it starts making a noise, and then I back it off. That's usually what I do. For the throttle, similar thing. There's a throttle at 1.5 milliseconds or 1500 microseconds should be no throttle. And then higher than that should be forward, and lower than that should be backwards. And then you just have to find these values again. The last piece here is just if you're using the PCA 9685, I've heard, I guess, issues with being able to communicate to that. So it communicates over I2C, like I mentioned, and I guess there's different bus numbers for that, and I2C addresses depending on the board that you use. I think on the Raspberry Pi, it automatically searches for it, so it can find it. Or maybe that's the bus number. Yeah, actually the bus number is one which it automatically detects it. All right, so that's what I have for the Donkey Car hardware. Any questions? All right, great. For the software, okay, so this is kind of my interpretation of it. I don't really know how to really draw it or describe it.
Well, one question is,
Sure.
what is the significance behind going over the hardware for what we're doing here?
Yeah, that's a good question. I like doing the hardware piece because at some point you will want to move to hardware. But for, I guess, how to connect it to the software piece and the software simulator, I'm going to talk about the Donkey. When I talk in the Donkey software part, I'm going to talk about how the Donkey software does this Donkey parts loop, which actually loops across the all the different parts and then manages those parts. To be able to hook into the simulator, we actually have to, Tons created something called a Donkey Gym part. And that's the magic part that basically when you stick that part in, it intercepts, it's basically seen as a camera, and it feeds the camera images in there, but it also intercepts the, or defines as inputs, the steering and throttle. And so that is the kind of the magic interface on how we can convert what we have now with this real hardware into hooking into the simulator. So, you know, maybe all of this is not required, but I think the background of understanding these Donkey parts, when I go over the software, actually, I'll talk about these Donkey parts. It helps to understand how that gets connected in and how we connect the simulator to it. So hopefully you guys feel that that's useful as well. If not, then, or if you're not going to hardware, then yeah, I guess you don't really need to know this part.
Cool, thank you.
I hope that answers it.
Yeah, it's just sometimes good to bridge the physical and the virtual worlds and understand if they're transferable and or not, and if they are, how. Cool.
Yeah, for sure. Yeah, and I think to me, one of the really, I was going to say critical, but it's not, critical is not the right word, but one of the advantages of using the simulator is you can do so much more in the simulator. You can test in so many more environments, but you know, that doesn't become, it becomes a moot point if you can't take that model and somehow use it to improve the real world model. So there has to be some transfer to the real world at some point. You know, otherwise, you know, we can take learnings here, but then we would have to kind of reproduce them in the real world and train the model in the real world to transfer it. But if we could, you know, take our simulator model and have it behave very similar in the real world, then, you know, I think that's probably the target. Like that's definitely one of the targets I'd like to be able to do, because then you can train so much more on the simulator. You don't have access to the track. especially now, you know, as Jack was mentioning, we can't even meet, we can't go to a real track unless you have one in your basement at home. But we can still do work in the simulator. So that's a critical thing. All right, so for the Donkey Car software, I was mentioning that, you know, this is just my perspective on how it's broken up. It's also, you can also see the files that are created. You know, I used to call software, you know, modules of software. I don't know what the right terms now, but you know, there's these functions that the software provides. I really see kind of three key aspects of that in the Donkey Car software. There's what I call the Donkey utilities, which is the Donkey command and all the subcommands. And in the call out there, I just say the Donkey command. That's what you install when you do your pip install Donkey Car. That's actually what you install. And then that Donkey script actually becomes available in any directory that you're in. And we'll go over some of the Donkey utilities, not all of them. The second piece, second package, I guess, is Donkey Car parts. And I went over this for the hardware. So I think of this as the software drivers for the different hardware pieces you have. So for example, the motors, you know, the PCA 9685, which is your interface to the PWMs, to the motors and the steering. The camera in there, you also, I think I saw LiDAR. There's OLED. There's a bunch of parts that have been contributed by the community. And then there's also software functions, such as the machine learning models, the data store writing, etc. So there's lots of functions in there. So if you go into the Donkey Car repository and you go into the Donkey Car folder and the parts folder, you will see that. And I actually did a screenshot of that folder later on in one of the slides as well. And then another piece of it, and this is done when you do your Donkey create car command, is you create something what I call a Donkey Car folder. They usually call it My Car or Sim Car or Pi Car or something. But when you do the Donkey create car, it creates a folder and it puts in that folder, it'll put a manage.py, a couple of other scripts, and then it creates a model directory and a data directory. And I'll show that as well. And this is actually Ton described this a bit last week. The reason they separated it out this way, they separated it out because they had the pieces that were more static, that don't change, and that's in the Donkey Car piece. And then this Donkey Car folder these are all your config files, and these are the scripts that really change depending on the hardware that you have. So what's on your Donkey Car, you have to define, you actually have to look to see what parts you need to add. You know, that's all driven by the manage.py script to configure that. So those are the three pieces. I know when I started, I was really kind of confused what each of these things do. The other really confusing piece as well is you do this create car. If you do it on your PC, it'll create the folder on your PC. And the reason you do that is because you want to call the training script, because that's where you do the training on your PC. So you call manage.py, but you call the train subcommand. You also do the same thing on your Raspberry Pi or your Nano. You would do a create car, and you would create a folder on your Raspberry Pi. But on that one, you don't do the training. You have to do the drive command, because that's where you do your drive, and you actually manually drive your Donkey Car. So that's also something that really kind of gets confusing when you start out.
Yeah, and a related thing is the necessity to have your configuration, your myconfig.py, be the
Right.
same on both. So you create your
X.
calibrate on your Pi, and you end up with your myconfig.py on the Raspberry Pi or the Nano. And then
Right.
before you train, along with your data, you should send your myconfig.py over to your PC, because those PWM values that you showed earlier, they need to be the same, because it's
Yes.
how far it's going to, the value that it's going to, the autopilot's going to emit when it infers a throttle or steering depends on those values.
Exactly. Thanks, Ed. That's an awesome comment. I actually did not point that out, but I should add that to my slides. Yeah, so what Ed was mentioning, and I'll just flip back to that because it's really important, is these are your calibration, or these are the values in myconfig.py. When you calibrate your donkey car, so you calibrate what left and right steering are, and how fast it can go, what maximum forward and what maximum backward speeds are. So you'll change this. It won't look like these values. And so on your Pi, you'll have, for example, let's say you change this from 460 to 480, right? That is what that's the value in myconfig.py. On your, sorry, myconfig.py on your Pi. Now, if you go to your PC and you've done that create car folder command, it's going to have the default value. So it's going to have these values in it. And so what Ed's mentioning is you have to take that myconfig.py that's on your Raspberry Pi and transfer it to your PC so that it has the same values. And the reason that that's important is when we go in the training, these values are actually not written to your control files when you're training. They're normalized, and so there's values written from -1 to 1. And what it does is it actually, when you emit your PWM from your controller, it goes to the Raspberry Pi and it spits out what the PWM value should be. It, at the same time, it will normalize that between -1 and 1 for the steering. And it does that by, I guess, taking this range that you have here and dividing it by the PWM value that you're trying to output. So,
and there are other settings like camera cropping or region of interest that actually sort of, they alter the image that is going to be inferred from, and therefore you need to have that same setting so you're altering the image when you train.
yes, yeah, and maybe that maybe I'll ask Alex. Can you write down some of these notes, Alex, and make sure we do a follow-up on that? But yeah,
you sorry. What
so I think the key point there is to make sure the myconfig, after you update myconfig on your Pi, you have to upload that to your PC. So when you do your training, it is training with the same configuration as you collected the data with. So if you cropped your image, when you're training, you have to crop that image. Otherwise, the model that you build in your training, it just won't match the data that you're feeding it when you're trying to do your auto drive. So those are really, really good points.
Okay, so I wrote down, after you update the myconfig.py, you have to upload the cropped images.
No, just say upload myconfig.py to the PC, and then we'll expand on that.
Okay.
Okay, great, thanks. All right, so yeah, so in terms of the donkey car folder, there's really, again, there's two part. There's the folder on your Pi, which is on your real hardware, and then there's a folder on your PC. Now, when you're in the simulator, I guess you don't run into this problem because the create card that you use, the folder is always on the PC. So you don't have to, when we're actually driving the car on your PC, so it's a little bit different. You don't run into that issue. But it's the same, it's an important concept that you have to train with the same configuration with which you drove your donkey car. I just wanted to put this out there again, so people that haven't installed the donkey car before. I just copied basically the what was in the donkey car software docs. This is just cloned from there. Basically, you take the source from the repo, the donkey car repo, you change into the directory, you check out the master. This part gets confusing for people as well. What this is creating a virtual environment for what you want to use this donkey car for. This is important in Python. I mean, I guess one of the strengths of Python is there's so many packages out there. One of the gotchas is that the packages all have different dependencies, different requirements. So, depending on the package that you're using, you might have conflicting requirements, or you just might not be able to install because of those conflicting requirements. So what this does, and there's different ways to have virtual environments. I actually like the Conda one. It seems works really well. So what this is doing here is just basically it's creating your virtual environment, plus inside this file here, it has all the dependencies on the donkey car package. So it's also installing those at the same time. And then what this is doing here, this is actually installing the donkey car script so that you can have the donkey command available in any directory. And so, and so that's this here pip install will do that. What this is doing is calling the install script, and with the environment that you want to install in. So if you're installing on the PC or installing on the Pi, it will install different. Packages. Okay, so just going back to the donkey car software parts, like I mentioned before, if you go into donkey car /parts directory, you will see a lot of scripts for different hardware, as well as scripts to do different functions, like the tub. Oh no, it's data store writer or something like that. Yeah, so data store, that's the tub writer. You can see there's a camera here. There's ones for, I called out the OLED. Oh yeah, so here I saw the LiDAR one. A lot of these I haven't tried at all. But if you have a more advanced donkey car, you might have, for example, this is like a 3D camera, the RealSense camera that gives depth information. So that's a driver for that. So yeah, this ties into the manage.py. So I mentioned in here, in the manage.py script, it will call the methods defined in these donkey parts. And I actually give a little bit more detail as well in a subsequent slide on that. I kind of try to show where that's done. So if you're interested in digging into the code a bit more, you can look at that. And for the simulator, the magic part is this donkey gem here, this dgem.py part. It actually is the one that interfaces with the donkey gem environment. The donkey gem package that you install, it calls a create environment to actually create that environment. And that's how it plugs in. And actually, once you plug that part in, You don't really need any of these other hardware. You don't need any of the other hardware parts, but you certainly need some of the other software parts like the tub writer and things like that. But so there is, I guess back to the hardware question, it's really good to kind of understand how we interface with the hardware, even from the simulator perspective, because you're basically hooking out the hardware and you're trying to hook in the simulated, I'll just call it simulated hardware or virtual hardware. All right, the third piece I mentioned was a donkey car folder. You create that using the command donkey create car and you give it the path. It doesn't have to be this path. The tilde stands for your home directory. The my car is just kind of your default name for your car. And, you can call it racer, you can call it sim. I've been using my sim just to differentiate it between my real donkey car. And inside that folder, you'll have the manage.py script, and you'll also have the default myconfig.py configuration file. So those default scripts, the default scripts and the default configuration file, you need to go in there and play with it to configure it to what you have. I think the defaults will work with the standard donkey car, but if you need to change, if you're different from the default, you need to go in there and update that. And that's where, I guess understanding what these config items mean is important. Whoops. Then as well, there's I mentioned the data and the logs directory are created. This is just I think a helper to help manage the files. I think actually you'll find that it's important that there's a data file, because every time you drive your donkey car, a tub data directory will be created. So you will get lots of tub directories, and those are put in your data directory. It's also recommended that when you train that you put your models in your model directory, and that just keeps your...
Quick question, if you don't mind.
Sure.
As we go to training and we have multiple tub files, usually they are auto-generated with a date.
Yes, yes.
So when I go to train and use the generic training command, are all of the tub files used to train the model, or only the latest one, or something else?
Okay. Yeah, that's a really good question. I think the default is if you do not specify the tub directory, you don't have a -- tub argument, then it will use all the tubs in that directory. Maybe Ed might correct me if I'm wrong.
That's
Otherwise,
correct. I can confirm that's correct.
Oh, okay, great. Thanks, Jack. Yeah, so if you omit your -- tub argument, then it will use all your tub directories that are in your data.
Any chance you could show what is the command to specify specifically which tub you want to use for training?
Yes. Can we park that until we get to the training piece? Because that's a really good question, and we will get there when we get to that training piece. But
and
yeah,
then, Paul, really quick, just a follow up on that is also, if you already have a working model and then you just want to collect a little bit more data, you don't have to retrain on your entire direct of data. You can then do something that's called a transfer model. So you're going to train, give a model number, give a new model number, and tell the tub. So then now your basically the inference is going to be based on something that's already worked. You're going to add some more data for it and create a new model. So you don't have to create, for example, a training that will take you like an hour or so. You can just do something 5 minutes. That's a go along with that. So I think there's 2 important commands, right? Just one the tub, if by any chance you think you can train out of one tub. And the second would be, you already have a working model. I want to add just one tub on the top of that because I thought it was really good data.
Right. Yes, that is a very good point. And you actually do not want to train on all the tub directories because the ones that you've already trained before, because you might as well go for lunch because it will take a while if you have a lot of tub directories and you're training on stuff that you've already trained before. So as Jack was mentioning, you can start with the model that you have and just add to it. And I normally I don't do that. I guess I should. I should start doing that, but I just collect the data and then I just train on one tub directory. I guess I'm not that advanced yet. I don't have that much data. All right, that was a really good question, and we'll cover that when we get to the training section. But basically, there's an argument that you pass to the train, which specifies the directories, and you can comma separate the directories as well. Okay, let's see, driving a donkey car. Okay, so the next section now, so hopefully that gives people a view of the software and what components make up the software. I'll also talk about the simulator software a bit later and how it connects with this donkey car software we just went over. But let's talk about driving your donkey car. So there's two pieces to the manage.py that I mentioned. There's the drive and the train. And you really have to remember that the drive, you actually have to SSH into your Raspberry Pi or your Nano and issue the command. If you do this from your PC, it's not really going to work. None of the hardware drivers on your PC are going to see any of the the hardware pieces. And yeah, it just actually I should try it. I don't know what error messages it spits out, but it's not going to work. So make sure you SSH into your donkey car, and then you issue this command. And so manage.py will now look in your myconfig and add the donkey parts that are defined in your myconfig.py configuration file. And just like we talked about, in the software section and in the hardware section, it will add all these parts and then it runs those parts in a continuous loop. I kind of think of it as a stack. I think that's the terminology they use as well. So it's a stack. You just add, as you add parts, you're stacking them on top of each other. And then you're just running those parts in a continuous loop, those parts in the stack. And then once it adds those parts, one of those parts is your controller. And that controller will feed the steering and throttle information when you're in user mode. It'll feed that. Your steering and throttle information, and that's taken by your hardware parts, and that'll move your donkey car and with the throttle, and it'll do the steering. So and I find this is also a confusing part for beginners with regards to the control. So I've tried to actually highlight that. There's different ways to control the car. There's a web browser and there's also the gamepad. And whether you're using the gamepad through the web browser or you're using the gamepad connected directly to your Raspberry Pi or Nano, they're really different. And so and they're going through different driver paths. So so debugging them is different as well. Okay, so here's my attempt at trying to explain how this works. So you have the manage.py script. It creates your vehicle object. Again, this is all part of the donkey car software. When it creates this vehicle object, it initializes it, and then it adds a bunch of parts. So in here, I've called out just two of the parts that it added. So it's adding the, what is that there? That's the camera part. And here, this is CTR, is the controller part. So there's a bunch of checks in the code depending on your myconfig what's in your myconfig.py script, and it will trigger whether to add these parts or not, and the types of parts added. So if it's a web browser, then this controller is a web browser part. If it's a joystick, then this controller is a joystick part. And that's what I tried to highlight basically here. So depending on, again, on myconfig.py and what you have in there, it will call one of these methods to add the parts in. And then once it's added all the parts in, it calls the start command, which is basically the loop that I mentioned, and it will continuously loop calling these parts. This is the stack that I mentioned. So if you actually go into manage.py and you search on v.add, you'll see that's basically what I did. I did a search on v.add, and then I just looked at all these different methods that are being called to add these parts. So for the controller, you can see there's a local web controller, and that is the one that serves up your web page. But if in manage.py, you give it the --js command, or you set in manage.config, use joystick to true. I can't remember the exact configuration value, but there's a value in there that just says use joystick. It will then call this get joystick controller. It won't call the web controller, so you won't have a web page being served, and you now control everything through your joystick or your gamepad. And then there's a bunch of
little modification there. There's been there was a community edition that has a first-person view. Now that actually uses the web controller, so you can be driving with your joystick, but watching watching the web controller to see where you're going.
Oh, cool. I didn't actually add that part in there. I wasn't sure what it was, but okay, thanks. So Ed was mentioning that there is, I mentioned this doesn't get fired up, the web controller doesn't get fired up if you have the joystick, but there's another part that you can also add, which is the FPV part, I guess web FPV, that will fire up, I guess, a browser where you can drive with FPV. So I didn't list all the parts, but I listed some that I thought were interesting in here. And so again, it's a stack. So the first one that's added is the camera, the controller is next, and then these parts are stacked on top of each other as they're added. The image pre-process, that's the one that Ed had mentioned with regards to region of interest and cropping. It will take your image and crop, for example, if you don't want the top 50 pixels of your image because it's all horizon and not interesting, you can do that. You can specify the region of interest at the top and also at the bottom of your image. The drive mode, I think those have to do with the user and the local angle or local pilot methods, and switching between those different ways of driving your car. And then the very last one that's added is the tub handler. That is the one that that actually writes the records to your tub directory at the end of the loop when all your parts have had the chance to provide their input, take the input, provide their output. This tub handler will take the inputs that you specify in terms of what records or what data you want to write into that control record. So normally you would write the image, so that's on a separate file, and then you, as part of the control record, you would write your steering and your throttle. And also it writes in the time, milliseconds, but you can also write in other values. I think if you had an IMU, for example, you could write your IMU accelerometer gyroscope values into your record as well. So that's how you can go look in there and specify what you want to write into your control record. Okay, so again, this is the parts is really critical to understand as well. If this is how the donkey car can support many configurations. You know, it's basically plugging in the parts that you need for your specific hardware implementation for the donkey car, and then, you know, if you're plugging a part that doesn't have a driver for it, you would just write a new donkey part and then update the config file so that you can add it in, and update manage.py so it would read the config file and add this part in if it was configured that way. So this is, you know, I guess from starting off, you might just be looking at it to be able to set the right configuration. But as you get more advanced and as the community adds more parts, you know, I think that the RealSense camera is kind of a cool thing, and, you know, maybe that can really make our donkey cars more intelligent, or other, you know, other methods for collecting data so that we can have more robust models. Yeah, and then this piece here regarding the run. So basically the parts are added in this order I mentioned as a stack, and so they'll be run in that order. Okay, so just a couple of visualizations now on driving the donkey car. If you drive the donkey car with the web browser, so you're not using a joystick, you don't have the --js argument in your manage.py drive command, you can then go to your web browser, which is at port 8887. It will be at the IP address of your Raspberry Pi. The example here actually I have is on the simulator, so I think I used localhost. So I'm kind of mixing up my screenshots here. This would not be your proper browser window for this configuration. But the web server here is on your Raspberry Pi. You open up 8887 and you put in the IP address of your Raspberry Pi. You'll see this window. You go to the default, it'll just say joystick here. You'll have your user mode. And if you click on here, you will drive, you can drive your donkey car. So up and down is your throttle, and left and right is your steering. So in here, the call out, I'm just calling out that you have joystick here, your user mode, and then you use this virtual joystick. Between your laptop, which has the browser, and your Raspberry Pi, you're communicating Wi-Fi. And this is just your browser information being passed back and forth here. The next configuration here, if you actually use a gamepad which is connected to your browser, then this is kind of what it looks like. You click gamepad here, and I'm showing a Bluetooth gamepad, but you could also have in this scenario, you could have a USB gamepad connected to your laptop, and you could drive your donkey car that way. So what's happening in this is the steering and the throttle information is being passed through the browser to your Raspberry Pi. So what's happening is the browser is actually getting this data and then passing it to the donkey car web server. And then the last configuration here is when you have the gamepad connected to the Raspberry Pi itself, and then the Raspberry Pi is now there's no web browser here. It's actually that it's using a device driver in Linux /dev input JS0 on the Pi or the Nano to read those joystick values. And so this is a separate joystick part, which is now controlling the steering and throttle information and feeding that into the parts loop. And so that's the those are the differences. I think it's kind of critical just to understand, you know, especially this Bluetooth to your Raspberry Pi and this Bluetooth to your browser are two different things, and just need to understand, because one of the questions I hear when I see the people using the simulator is, you know, why can't I use the simulator with my Bluetooth? And you can't use it in this configuration where you're using the Bluetooth and the joystick driver is what you're trying to use, and you're on Windows. So that's just it's just a little bit of a nuance. It's just because the Python software, Donkey Car software, it doesn't work well in the non-Linux, which is, you know, in the Windows environment. You need the dev/devs/input/JS device for that joystick part to work properly. Okay, so that's the driving part. So now we'll get to the training part. Let's just time check here. So great, I think we still have good time to cover the rest of this. All right, so training. The training documentation, I think, is actually really detailed on this. If you go to this autopilot, they talk about that. And I think even Ton also talks about some of the optimizations. I might talk, I'll touch on it, but I won't talk about all the optimizations in terms of, you know, I guess the first thing to do is to drive within your lane and do as many laps as possible within your lane, and collect good data. And then once you have that, then you actually want to also train your model and give it data on coming back into the lane when it is lost, and, you know, when it goes out of the lane, to come back in. And the tricky part in that one is you don't want to record the data of you leaving the lane, because you don't want to teach your model to leave the lane. But what you want to do is record your model coming back into the lane. And so those are kind of advanced training data collection that you want to do and to make your model more robust.
Yeah,
So
I think it's worth mentioning when you're collecting your data. So, and I recommend to everybody use a game controller. You'll be very frustrated with the control in the web.
We're in quarantine. Some of us don't have access to a game controller.
Yeah, well, save up, save your allowance. So, but this what I'm about to say is the same for the web controller. There is a command, and you have access. The reason I mentioned the game controller is you have one button access to this command on the game controller when you're driving on the game controller, which
right.
There's two settings I always use when I'm using my game controller to collect data. One of them is in the joystick section, and it says auto record on throttle. So you're not starting recording until you actually give it some throttle. Then it'll start recording. And as soon as you let go, it'll stop recording. And then the other setting is there's a button which will let you erase the last 10 seconds of what you recorded. So when I train, I have those two things. So I don't start recording until I hit throttle. And as soon as I know I'm going off course, I'm going to crash into something, I just let go, stops recording, and then I hit that erase 10 seconds button. And if between those two things, you actually never have to clean.
Yeah,
the
just
data.
a quick correction. I think it's 5 seconds is the less
Might be
200.
yeah,
So
maybe
if you
5
have
seconds.
20 hertz times 5, then that's 100,
Right.
but it's like 5
Yeah,
seconds.
last 100.
Seconds would be a lot. Would be a typical lap, and if you're driving
Yeah.
fast, so it's half
Yeah.
of that. It's 5 seconds.
Yeah, sorry, you're right. You're right. It might even be 1 second. It might be a lot less than that. But the so it's going to erase what you just did to get into the bad situation, and it won't
Right.
record the bad situation. Now you're off the track, and now take Paul's advice. Instead of just popping it on the track, have it off the track and drive back onto the track. Right?
And record
it's going
that.
to record you driving back onto the track. So it becomes a very sort of natural, hey, I just crashed, but I didn't record any of that data. Now I'm going to record data getting back on the track if I'm off it. And then you'll just naturally start to accumulate this data.
Right. Thanks, Ed. That's excellent advice. Yeah, I also agree that the game, your gamepad is the way to go. I'll just quickly go. Like, this is the configuration that you want to be driving your car in. The reason for that as well is that the joystick part that I mentioned, the joystick driver, it maps a bunch of your buttons. Because it's reading the buttons directly on there, it can map those buttons to functions. So it's not just steering and throttle. You have, these gamepads have tons of buttons. And so, I've seen you have like AI launch, you have delete your last 100 records. You have your user mode changes, so you can go from user to local angle to local pilot. So you can change your mode all through your joystick, and it really is much better. I think starting off, it's good to kind of understand this interface, but from here, for example, actually I'll go back here. In this configuration, the web browser is only set up to read the throttle and steering information. If you press these other buttons, they are not set up currently to read any of those other buttons. I mean, I guess I can pass on Tan's advice. If you want them, you can go ahead and code them. But if you can code the web controller to read these buttons and pass them on. But right now they are not in there. So you don't have those, fancy erase the last 100 records. Or actually, Ed said maybe that's on a button in here now, but there are, you don't have those as you do in this configuration. So excellent point. Yeah, so I guess kind of point one is collect data and collect good data. And the easier you can make it to collect good data, then the other point where you don't spend as much time cleaning your data. And there is I'll talk about Tub Clean, which is a utility to help you clean your data. But you spend less time with that. So if you don't record yourself going off the track, or you erase the records with your erase last 100 records button on your gamepad, then you record yourself coming back on the track. Then you start building a really good data set for your model to learn from. So I show this as a loop because it really is a continuous loop, improvement loop. You're collecting data, you transfer your data to your host PC, you train your model, then you transfer the model back to your car, then you test it by going into autonomous mode and seeing what it does. And then if it stays on the track, great. Now you give it other scenarios that it needs to be able to handle. And you just continue, you just continually do this. You can drive on a different track, you drive in the opposite direction. You just keep building your data set for your model. And you know, this is where we also can touch on the question about you know, how do you train from a specific tub directory. So in here, you can train across all your tub directories or a specific one. You know, the recommendation, Jack made a great recommendation. You just augment. So when you have new data, you just take your current model and you train on the new data, and you learn that information from your existing model, and you add, you know, the additional, whatever additional information it can take from the data that you're adding to it. Okay, so how do we do this loop? So let's step through each of these. So collecting data, you start driving.
Oh, as you get into this, I'm not sure if this is the best time or not, but to kind of touch back on the point of the, maybe this is later in the presentation, but on the connection between all the files and the databases and so on and so forth, between the sandbox, the gym, and the donkey car, and how they all connect and work together, and the difference between a client and the local sim.
Okay, yeah, I go into that when I talk about the simulator. So
Okay, cool,
can
cool,
you
cool.
just mark
I
that
just
for
wanted
there
to
as
bring
well?
it up in case it's relevant. Okay.
Yeah, yeah, it is. It's a really good question, but yeah, well, I've talked about the donkey car software right now up to, you know, to now. I will plug in the, you know, how that's connected to Gym Donkey Car and the SD simulator in when we start talking about the simulator. But yeah, I think that, you know, the other thing to remember is that I'm talking about driving a car here, but what I'm talking about here is totally applicable to the simulator scenario. So you issue the same command, this Python manage.py drive, you know, but instead of SSHing into your donkey car, you can do this now right on your laptop. So so these commands that we talk about, this workflow loop, you know, for training, is exactly applicable. It's the same workflow whether you're trying to collect data from the simulator and train the simulator, or you're in the real world and you have a real donkey car driving around a track. The actual workflow is the same. You know, where it will differentiate is where you're issuing these commands from. And I'll highlight that. I actually have I think I have a good diagram that shows that, the comparison of those two. So hopefully when we get there, that should answer that question. Okay, so in terms of driving the car, you basically, this is the command that you issue. If you're using a joystick, you would add --JS here, and that would invoke the joystick part and add it into your vehicle part stack, like I was talking about earlier, and it would basically replace the web controller part. Just what I'm highlighting here, one of the things that was added is the tub writer. Although it's not called a tub writer, it's called a data store part. And what this here does is it's created, so it creates a directory, and this is the directories, you know, that people mentioned. This is a default name, tub _, and then this number, the tub number, will increment every driving session that you have. And then it also appends the date to it, so that it helps to separate out your tub directories and also when this data was collected. And so I'm just trying to point out here that this, you know, that is automatically created as soon as you issue the drive command. So now that you do that, you go to your web browser, you go to the gamepad, you start driving around the track. It will then collect the data and add it to your directory. In terms of toggling recording, there's actually three ways to start recording. On the web browser, there's a button that you press. You can also configure auto record on throttle. So Ed mentioned this. Set this to true, and every time your throttle is non-zero, it'll start recording. And this is true actually of, it's true whether you're using the web browser or whether you're using, it's actually true in any scenario. So let me just go back here. In any of these methods, so whether you're Bluetooth, on the Bluetooth direct, Bluetooth to the web browser or the web browser, whether as soon as you're non-zero throttle in any of these methods, it will start recording. Just wanted to point that out. So it's not just, if you're using a gamepad. And then the last one here is having a record button on your gamepad as well. So you could, as by default, a lot of the joystick models, so there's different models that are supported. It will have in there, a lot of them by default will define a record button. And so, you can just press that button to toggle between turning record on and off. So those are ways to record, to toggle the record button. As Ed mentioned, I would say probably the majority would just turn this on and just forget about it, which makes sense because when you're not moving, you probably don't want to collect the data since there's really nothing to collect. And then when you start moving, you just want to collect the data. So it really kind of is convenient that way if you just set it to that value and you don't have to worry about it. And then have the kind of the erase 100 records button available so that when you do drive off track and you're recording, you just erase those records. This, I just wanted to show that in the web browser where it is. So it's just this button here. You can hit the button. If you have auto record on, then as long as you use this joystick, virtual joystick, as long as you're moving it around, it will just auto record as well. Okay, so you've driven around, you've collected the data. It's now sitting in your tub directory. You have to take all that data now that's sitting in your Pi, and we now transfer to your host PC. The reason for that is because we want to train on that data, and the Raspberry Pi isn't really powerful enough to do the training piece. Or I don't know, maybe it is, but it'll just take hours. Or maybe that just means, if you say it takes an hour, then it's not powerful enough. So, so basically, you transfer it to your PC, and you do the training on the PC. Now, on the Jetson Nano, that's actually a different story. I believe you can do the training on the Nano. I haven't done it yet myself, but I guess if people have done it, they can pipe in here.
Adam Conway, I know Adam Conway started when he first built his car with the Nano. He started that way. Because then you don't have to do the transfer from.
Right.
It's all, and you don't have to remember to transfer your config and
config,
all that
exactly
stuff.
Right.
And at at the 10,000, 15,000 record level, I think it's adequate,
right.
Under an hour. But I think once you start to get a lot of records, like on my standard Donkey car, because I've been using that same car for 2 years, I have like 85,000 records.
Oh wow!
So that wouldn't work very well on a Nano. You'd want to start to work on a PC. So it depends on how many records.
Right.
Maybe I add. I tested it at the Bosch Upstart course with about 10 minutes of driving. I think it was something like 5,000 records. Took almost an hour to train, and it was able to drive the train without any additional data into the data set, and it worked quite well. And I even tried to transfer it on an outdoor track, at least it followed part of the lines, not perfectly, but so that's very interesting, and getting more into training on the Nano, because you spare all the transfer. So and Torn was I think the one who gave the tips what judges what knobs to train or to switch. I can share that.
Yeah, in
Well, so
particular,
just like for my 2 cents, right? It's all about the pain and how much time you have in your hand. If it
Yeah.
takes 1 hour to train something, how many 1 hours you have in a day, and how long you want to keep your students engaged.
Right.
But few of us have ways to go. Just use Colab. It's free.
Right.
If you have an AWS account, right? Time is money, so it's up to how you use your time, and then how much time you want to go around going back and forth. So you may want to consider not training on your Nano. You may want to consider not training your computer unless you have a nice CUDA GPU, or if you don't want to spend money and you have the time, then just keep doing it.
Well, I learned it the hard way. I had no Wi-Fi at the Maker Faire. I had no Wi-Fi at the Bosch location, so there was no other way of really getting it very
No,
easy.
there is a way. You make a
Yeah.
car be an access point. Yeah, there is a way.
Yeah,
You don't need anything external. Of course, you can then make your computer be an access point, and when you boot, your car go connect straight to your computer. You can just connect a cable, then go point to point, and yeah, there is several ways.
yeah, you can do that. I also use a really fast thumb drive, super fast thumb drive.
Yeah, and then
Patriot.
you bring your little travel router if you really want, so just as a backup. Of course, at that point you couldn't by region, but yeah, you can do different ways to get to that just point to connection, then transfer back. Yeah.
Yeah, as a matter of fact, I always use the thumb drive anyways, because as part of the workflow, you make a backup, which I like.
Right. Yeah, that's a good point too.
Is there any documentation available? Because I know there has been talk about the thumb drive. Is there a link or anything available at this point for how to make a thumb drive?
What do you mean? It's just like when you plug on a Linux machine, or then you mount, right? Then you just do a copy transfer. So you have to find a way
Yeah,
to
I'm just using it
Just-
for data transfer,
just
not.
Yeah,
yeah.
it's just data. Yeah.
Yeah, and then you transfer that, then you eject, then you bring it back to your computer. If that's the path you want to do it, I think it's one Echo strap that you may or may not want, but as Ed was saying, he likes to have a backup, so that's fine. I think it's take longer if you're doing that way actually. So, but all right. So yeah, it's just a regular drive. You mount it on a Linux machine when you plug on your Raspberry Pi.
Keyword is Linux machine. Not everybody has a Linux machine.
No. That's not what I meant. So when you have no option, right?
Yeah.
Your Donk is already running on a Linux machine. So what I meant is that when you plug your USB thumb drive there, then it's mounted as a drive. So you format it in NTFS, then you can run that you can read that on your Windows machine. That's what I meant. It's just a regular drive.
Yeah. No, it's completely understood. Just asking the question really for anybody else in the who's listening right now, who's wondering how to do that. So thanks. Thank you, Jack.
Yeah, I think that, so the key thing there, so that, just to summarize that discussion, you need a place to train with all that data. The workflow model that I'm describing is, you have your PC, you just transfer it from your Pi to your PC, and you train from there. The other methods suggested, you can transfer it using a thumb drive, or you could transfer it to an online cloud, Colab, AWS, where if you have access to that, your training can go much quicker. So those are all excellent suggestions. And, especially if your data set starts to grow large, like Ed was mentioning. I've never had to train for an hour. I guess I just don't collect that much data. I just like Jack was mentioning, I'd probably just cut my data set and try to get the model working with smaller amount of data. But I think the key piece there is get your training data that you have, get those tubs, get them to a place where you can issue the train command. And so once you do that, oh, sorry. Oh, I didn't actually put that there. Okay, so once you have that there, you can issue the train command. And before you train, you can actually clean the data. That's why I put this slide here. So this tub clean utility from Donkey commands, what it does, it's actually a really nice interface. You give it the tub directory where your data is, and then it shows this screen right here, and from here you can hit the play button. It'll play the files, and then you can see where you go off track, and then you can then basically hit the split button, and it will split that out, and so you can actually cut out scenes where you're off the track, and then you can delete that from your tub directory.
Paul, where do we find this? Yeah, where do we find this?
It's a Donkey command, so you just type Donkey, and then the sub command is tub clean, and then you pass it your tub. So when you installed the Donkey car software, so way back at the beginning, I said you issue the Donkey create car command, and give it the path and so forth. So this is just another Donkey. Yeah, I call it
So
sub
if you're in
command.
the Donkey environment, and then you call the command line prompt would look like Donkey space clean.
Right. Yep. So this Donkey command is available from any directory because you installed it. It's part of your path. So you can go issue this. Normally you'd be in your car directory. You would issue your Donkey tub clean, and then this would start with data. So it would say data/tub, and then your tub name. And then actually,
Is there any way
no,
we could show people, I don't know if you have it up and running, but if we could show real time how to bring up some of these important utilities.
yeah, sure. Let me go here. Whoops. Okay. Where's my other browser?
Yeah, someone else is also asking if you can post the command, please. So it might be helpful to, if you don't mind and you have it running, to show people how to bring up these tools, how to call them.
Yep.
Yeah, and the command is in that slide there on the at the bullet point there, Donkey tub clean -- tub path to tub folder. That's the actual command.
Yep.
Path to tub folder would be your data directory, so wherever that is.
Ah.
Yep. Exactly. Yep. So that's what the thanks, Ed. So that's what that's referring to. And then let me go here. Where is my other? Oh, it's this one here. So I've had my this Donkey car has been running the whole presentation. It's still running. That's pretty cool. So in here, let me go to. Okay. So I have to run a command, and point to a directory. So
Paul, we can't see your screen. We still see your presentation.
okay. Let me share. Thanks for that. I will share the screen. Is this the one I want? Yeah, screen 2. Okay. There, now I'm showing my screen.
Plug in your laptop too.
I'm sorry?
Looks like you better plug in your laptop.
Why?
Yeah.
Oh, is it?
That's what it says.
Where
Oh,
is
that's mine. Sorry.
That's okay. Thanks, Ed.
We maximize the screen so it'll be a little bit easier for folks to see. And just in the background, it looks like Paul is running on Windows, but he installed Cygwin. And to install, so Cygwin is an environment which basically converts Windows to Linux in short terms. And you can run Linux commands instead of Windows commands. And but it does take some effort to install Cygwin. Correct me if I'm
Yeah,
wrong.
it does. It does, but it's totally worth it. Yeah. I mean that could be another topic, but so in the instructions you install Conda, and for a Windows install you install Conda, and then you can bring up a Conda window, which gives you a similar environment. So that's that's another way of that's the standard method. Okay.
But you'll
Okay.
still
So
have to use Windows commands, right? Like to list the files in the directory instead of using ls.
in Conda you do, yes, but if you install Cygwin and the Bash script, then you actually get, like, I can do ls in this environment. So
Yeah,
so it's very useful.
yeah, it might be a point to bring up to people so they understand that you're not running native Windows.
Yeah.
In
Yep.
case they go to Windows and try to type in same commands and they don't work, they won't work.
Right. Okay. Oh, sorry. I didn't go into my environment yet. Okay. There's my Conda environment. And now I will. Okay, so this is the command right here that I just issued, which is equivalent to
Any chance you can
this
make
here.
it a little bigger, the Cygwin screen terminal?
Yeah, it doesn't really make the font bigger.
Oh, okay.
So let me, okay, here we go. I use control.
Thank you, Paul.
Okay. The path does not exist. Oh, wait a sec. I just have to give it. Okay, so this, I guess I don't need the tub. I don't need the tub qualifier. Okay, I should fix that. You just have to path it. Okay, so it'd just be like that. Okay, so now basically now it's starting up a web server listening on this port, 8886. Okay, so now I would go to, I would go here, and I can now go to localhost, but not 8887. I want to go to 8886. And then these are all the tubs that I have, right? So I can just, I don't know if I want to delete any of this data, but let me go to, let's pick one here. All right, so now all it's doing is it reached into that directory and is now displaying all the image files. So let me just Control Z this thing. Oh, I hope I didn't wreck it. Okay. So now I can play this, and it will play. And so if I go off the track, I can pause it here, and then I can split it, right? And then I can play it again a bit further. I can pause it again. You know, let's pretend that was me going off the track. I split it, so now I have this. This here is let's say a scene where I'm off the track, I can now go and delete that scene. So this is just, it's like a simple movie editing GUI.
Would you mind posting the link to the presentation of this information either on here or adding it to the OAVG GitHub
Which presentation?
with the link for this tool?
It's in Donkey Car. It's already it's already part of Donkey. You just have to do this. Okay, let me start again.
This presentation. Yeah, the
Oh.
one that you're on right now. This
Oh
one.
yeah, sorry, I didn't. I meant to start with that actually. I should have started with that. This presentation, if you go to the GitHub for the Ottawa, it's all in that the workshop. I'll add it in. It's added in there, but I'll just make sure we point it to people as well. So I did add that in. Okay, so
Thanks, Paul.
yep. All right, let's see. 3:40. Oh, okay. Now I'm behind time. All right, so tub clean. You remove your old data, then we move the data to the host PC for training. Oh, sorry, I'm going backwards. No wonder it's not making sense. Okay, now we want to do the training. We take the model and we pass it. We transfer it back to the Raspberry Pi. So once you have the model on the Raspberry Pi, you now drive again. So you issue the same command. Oh, sorry. I don't really want this one showing up. You issue the same command, but wow, this is really, every time I move my my mouse, it's changing slides. Okay. You want to now pass it the model. That's why we have -- model there. And now when you go into autopilot mode, that is the model that will be loaded and do the inference. And hopefully, if everything works, your Donkey Car should start auto driving itself and driving around the track. So when you drive, there's actually 3 modes when you drive, and this I alluded to this earlier. There's user, which is normally what you start in. Then you go to local angle, and you can then go to local pilot. If you're using the web browser, you switch between those modes using this drop-down menu. If you are using the joystick, you switch between the modes using the button that's assigned to the mode button. And every time you press it, it will just switch and loop between these modes. So you just keep pressing it. If you hit user, you go to local angle, then you go to local pilot, then you go back to user. So you can just, you switch between the modes that way. So once you've done that and you're driving, then you're now watching your model, you're seeing where it doesn't work, and then you go back to your collect data step to collect the data that you need to teach the model that, to teach the model the behaviors or the scenarios that you want it to learn. Okay, Donkey Car utilities. There are utilities to also to look or to plot the data. And so there's to plot the histogram of your steering information, throttle information, to plot the prediction your model is making versus maybe the manual input that you had. As well as there's this make movie command, which I found useful with the salient option, which gives you a visual indication of what the model is looking at for the different images. And so this is the example here. This is the histogram, the steering. This is user angle. So that's the nomenclature in the data set. The angle is what the steering is. So here, this is very there's a lot of right turns on this track. Obviously, we're going clockwise and it's oval. So you can see there's you know, just lots of right turns. I used constant throttle when I was doing this, and it was at 0.3. So, you know, majority of the records was data, the throttle at 0.3. Here, these are predictions. So the blue line is what is the steering angle that was input by myself, and then that image fed to the model. This is the steering that it predicted. So yeah, you can see that it was pretty. It's probably overfitted to this data set, but it's following it pretty closely. This here is a make movie, the salient option. So what it's doing here is it's showing the what the model thinks is important in this perspective. So the highlighted red and yellow and kind of blue dots in here is what the model thinks is interesting. And let me just show, I'll just quickly pop this up here if I can get it. And so this here is just what the movie looks like. So it's just, when you do the make movie, it actually builds a movie, and each image, it passes to a utility, some Keras visual utility that will add the colors to the image. And so this is, and so you would look at this, I'd see that it's looking at the horizon, so you might want to crop that. But it really is focusing on a lot of the lines, so that's also good. Yes.
A question. So to possibly make this virtual environment transferable to the physical environment, is there, can you take those cones, for example, and just focus on those, or just the lanes and not focus on the horizon, other than cropping, by, let's say, weighing the objects such as lane markings more than anything else? And so as you go into the real world, where you have the same lane markings, that would make the model still work. Would that?
Yeah, so so basically, what you're saying is, how can I tell my model what it should be looking at? And you know, that's all the whole machine learning part of this is that you're not really, you're not trying to guide the machine and tell it what it needs to learn. It needs to learn it itself, but you could augment or somehow enhance the images so that it will help the machine learn.
Oh, can I add something?
Sure.
So the answer is not with the current AI framework. It's looking for every single pixel, and from there trying to inference like features that help me. And then if a sun show up in there is a feature that has some contrast, the sun is going to show up. So one way you could do this, you go for some of those tutorials that people say line finding. You can find a bunch of those in YouTube, and then you apply that for the image before you feed them to the neural net. And then that basically says, all right, it's just going to show up, and then everything that's not aligned, I don't want to see in my image. For example, the horizontal, we'll get rid of it, right? And then you can draw areas of interest also. The trick part of that is that then now you're going back to almost like a traditional computer vision and not using really neural network. So it's somewhere that is a balance, right? So you can use a hybrid. We can do as is and see what's the limitation. And that's why this is not very robust, right? For those of you that try and go to the real world, it may work in the morning, in the afternoon will not work unless you really generalize and get a lot of data. And that's what makes the beauty of it. A lot of people just make sure it works and so, yeah, I know everything about autonomous cars. And the answer would be you don't. This is just one tool that can help you do some fast prototyping. And I can tell it's not robust, right? I wouldn't put my family to be in a car like this and press the button and then go do one single curve. And I hope you're not going to do this, because you could put that in your car, and then if you have ODBC connection, then especially you that work on the automotive industry, you know, you can control cars fly by wire, and I wouldn't drive my family in a car with this framework. So the point is, it's very good for us to start and to have exactly the discussion, right? I say this, and then I say it's triggering something on the neural net. What can I do? Well, we can apply filter and help the image to clear up, because you cannot do magic, right? Then you can clear, and then maybe just apply the line, everything else get dark. And if you go take a look on my class, you see MAE 148 HSSD, there are several filters that my students go apply and trying to make the framework more robust. But is that, again, it's just a trade-off, right? Am I using the traditional computer vision? I'm trying to go straight to deep learning, or they have a hybrid mode. So that's the whole thing is here, it's to experiment, right? So the answer would be as is, you cannot go there and say, hey, let me click on this and get a little height and get some points if you stay here, and if you ignore the orders, and there is no tool as is today on the framework, but you can change that.
Thanks, Jack. That's a really good answer. Yeah, I think it's almost like the question is, how do we teach the model to drive like we would have driven? Like, we know the things that are important to look at. And, these filters Jack mentioned, I've seen people do this image segmentation to try to segment the sky from the road. And it looks, then it looks like a cartoon, and it's obvious which one is which. But yeah, those are, you're now getting to the part where how do we make these models really robust and work really well? And the suggestion on labeling the lines and things like that, like that's just, it doesn't work, because it just doesn't work in the real world.
Right.
Right. So
Yeah.
you need
And-
something that already knows how to figure out the lines.
Yep. And to that point, Tesla just announced that they're investing in augmented reality to train their cars, meaning they want to use basically something like this to where they simulate their cameras. And so, another interesting point might be to people is, oh gosh, can I train a car in a Donkey Car Simulator if I change the environment, or maybe in, Grand Theft Auto or something like that, where there's a lot more scenarios? Ed,
So
you're
you want to autonomously jack a car? Is that what you're?
yeah, you could do that too.
So one of the things about the Tesla thing is interesting, because they're using machine learning to figure out how to synthesize a realistic image, right? This is a Unity environment with textures and a 3D thing, and it's what it is. What Tesla's investing in is actually being able to recreate a realistic simulation environment using machine learning. So they've got a ton of machine learning on the other side that's taking their real world data and then using it to be able to simulate an infinite number of virtual worlds, which is pretty interesting.
And where are they getting that data from?
Their cars.
Their cars? Okay.
500,000 cars with cameras in them.
So
Yeah,
a place
that's
like
amazing.
Michigan, for example, they're going to have a tough time because Michigan just allowed sales of Teslas. So there's not that many Teslas here. That means they don't have that much camera data or images of what Michigan looks like. So they're going to struggle with this region.
Yeah, and we'll see with other states. I know, of course, in the Bay Area, if you throw a rock, you're going to hit a Tesla.
Yeah, yeah.
Right. Yeah, that's excellent discussion. But yeah, I would say that is an advanced topic, and is a lot of, Jack is trying to solve that problem. It's hard. Okay, so let's I'm going to do a time check. I've got 5 minutes to, I'm not going to finish this the next 5 minutes, but I'd like to keep going on. So people, if you are able to hang around, please hang around, but I'd like to finish the presentation. If you need to leave, that's fine. I think we're recording this, so hopefully we'll have this where people can come back and access it later.
Yeah, I think in the recording, if you don't mind, Paul, maybe you can share the link and then we will send it out to our respective meetup groups as an email, and then people can get the link to the recording that way. Would that work?
Yes, yep.
Perfect.
Okay, so, all right, so we've done it. We've built our self-driving car. And then this last bullet probably talks to what the last discussion was about. So we made it go around a track. Some people will say, well, that's not very hard. But how do you make it go faster? You just can't bump up the throttle. How do we make it go different tracks? How do we make it avoid obstacles, other cars, detect signs, whatever imagination. Someone mentioned about how to detect lanes. So that is your training loop. And now I just want to, this example. So I just have examples of some tracks. This is really the donkey cart racetrack, looks similar to this. And that's what we race around. So now I want to spend, this probably is, I would say probably another 15, 20 minutes on the simulator and how the simulator is connected into the donkey cart software. So the simulator itself is really two packages. It consists of the GYM donkey car, which is a wrapper around the OpenAI GYM. OpenAI is an environment which allows you to create simulated environments, have an actor go in there, do actions, and then it would return back a result with regards to a reward, and then you would calculate a reward or a punishment. And it's really for the reinforcement learning aspect of this. I think Tom mentioned in last week's presentation, there was researchers using his simulator to do that, and they wanted to have they didn't want it bundled with the simulator itself, and so he pulled out this interface, and then he had the simulator, the self-driving sandbox, as just an executable, which is invoked from the GYM donkey car environment. So you have that part, the GYM donkey car, and then you have the simulator.
You just touched on the topic of the sandbox and the GYM environment. So the GYM environment, the sandbox environment invokes the GYM environment. So when we're installing stuff, we're installing the donkey GYM, and then that invokes the sandbox. Or sorry, we're installing the sandbox, which, well, actually we're installing all of them, and then the sandbox invokes the GYM. Well,
it doesn't really invoke it. I'll show it in a later slide. The sandbox is a standalone executable, and its interface into there is with TCP/IP sockets. So you communicate over TCP/IP as a client, then the sandbox is a server. Let me just actually, I forgot to answer a question when regards to training. So in here, when you train, it's this one here. So this is the command for training. I got to look at this screen. Oh, I can't highlight. Basically, this is how you specify a tub. So there was a question about when you train, how do you give it a tub? So here's the command, Python. I'm normally in I'm already in the my car directory, so I don't have to specify. This is the absolute path to the manage.py command or script. I pass it the train. So this is the train command, and then the argument is the tub, and I give it here, it's comma separated tub directory names. So this is kind of the magic. This is the answer to that question. You give it dash dash tub, and then you give it the tub folder name. And then you also pass it the model name that you want it to write. Okay, I wanted that. Important to put that in the recording too, because we did say we were going to catch it later.
I think it's important to try to help people understand how the different utilities and apps that they're installing interact with one another. Yeah, perfect. Maybe where does the sandbox go in this slide? Where is the sandbox?
Right. Okay. So let's go back to talking about the self-driving simulator. So the simulator itself, as I mentioned up here, it's made up of this Jim donkey car. Oh shoot. This Jim donkey car and this sandbox. Now, this is the name of the repo, so that's the name I gave it here, SDS sandbox. In my other slides now, Ton starts calling it the SD sim, so self-driving sim. So now I'm going to refer to this as a self-driving sim. So the simulator, the Udacity, or sorry, not Udacity, Unity game software is this here. I'm representing by this block, and this is a server. So this is the executable. So this is what you fire up. You know, when you said path to sim, that was what the executable that you pointed to if you wanted that to be fired up automatically when you started your manage.py and drive command. So this is the executable. This is the Jim donkey car repository. This is a separate package that you install. It has an interface, an OpenAI interface to it. And that's what, if you look in that package, you'll actually see there's Ton divided it up into like an environment folder and a core folder. So I kind of put that in there as well. And so this guy is acting like the client to this server. So this is basically the driving client to the server. And then now here's your donkey software. So when you do manage.py drive, and it started that vehicle and did that parts loop, the magic part that does the simulator here is this donkey Jim part. So if you look in the code in here, this code calls the create environment, which is in this package. It's actually in this module here. And so this, hopefully this is describing what you were talking about, Alex, in terms of what software lives in which part. So when you start the donkey car software, the manage.py command, and you give it the drive command, and it creates your vehicle, and it adds the vehicle parts to it. And if donkey Jim equals true, it will add this part to it. And this part is what fires up the simulator environment.
And the sandbox.
Well, no, okay. The sandbox here, this here will only be fired up if you set the path to the simulator and it's local. So you have to remember that, right? If everything is on your host PC, then you could say sim host equals or sim path equals and give it the path. Then this command can fire up. It can go into your path and fire up that executable because it lives on that host. But it doesn't have to be that way. This can live on a different server. So, and that's the way I like to run it, is I say I put the sim path as remote, and then I give it the sim host address. Now that address could be the loopback address, which is 127.0.0.1, but and in that case, I have to manually fire up the simulator. So I don't want every time I issue the donkey drive command, I don't want to fire up the simulator. And that's what happens. Like when you, in here, when you're driving, when you issue this command, manage.py drive, and in your config, my config file, you say set, you have your gym environment set to true, then, well, what does that do? Okay. Then it doesn't fire up the hardware parts, but it will fire up the simulator. And then it will add the parts to the simulator. It'll add that part to your vehicle loop, and that part basically takes over and becomes your camera and takes your input for your steering and your throttle.
Okay, and then where is the sandbox part fired? It's as when you connect to the server?
So now, okay, so here, this part here, well, what do you mean, what sandbox fired? It's,
Where does the sandbox part come in?
okay, so I think maybe the confusion here. So the sandbox is another name for simulator, right?
Okay,
So the executable, right? It's the simulator part. It's the game that you see, right?
Guys, you're not gonna like I'm gonna tell you, but I think you're going too deep. If people have not seen this, if you announce this workshop as being okay, let's go dig into the Donkey framework and the parts, and I'm all for it, right? But if you're trying to get people to be ready to race or to experiment with this, I'm not sure if you're going to start to lose people versus, look, you follow this configuration, you're going to call the simulator, you can then start to redesign the neural neck as you want, and not quite sure if it's relevant for them, who's calling what and what part is calling what, for, with all the respect, right? Depending on the goal that you want for this seminar, they want people to start and then collect data and then train and then eventually train their own neural network, or they want them to modify right away the framework. Because if someone is listen to this for the first time, I was so confused, what do I really need to do? Do I have to go dig on that? And that's not it, right? Once you do that issue, the Python manage.py drive, it called the simulator for you, right? It's already loaded the race, and then what do you have to do to drive? Well, you can use the web interface, be my guest, keyboard is all ready to go, or you can put a Bluetooth controller that either connect through the web interface or connect to your computer and then just simulate to be a JS0 and no web interface, and bang, you're already there, you collect your data, then your data, it's already on your data part, then here's the command for you to train, then you go back to the simulator and then you do the same command I had before, right? Python manage.py, and then you drive with the model and see if it works. And then that's a black box at that point. You get people excited about it, and then people say, "Oh, sure, this kind of work, and nice. So let me see how it is." And if we get too much on the discussion, what parts call what, I am with you. If this was an advanced workshop, but I thought you're trying to do an introductory workshop so people to get ready to use the simulator or not. Did I miss a point?
Yeah, you make a good point. I mean, I guess there was questions about the software structure for this, so I tried to go over that. I guess if it's not interesting for those beginners, then this part of the presentation won't be interesting.
I appreciate, right? Like, none of us are making money of this, and you're trying to be volunteer here. I'm just worried that people that now probably think, oh my God, this is so complex. Do I know to know all this, even to use the framework to start using it, to get my computer to go and collect some data to see if I really like this or not. And that's why I'm trying to, anyway, that was my comments. Why do you want to go that deep or you don't want to go that deep, and just right away show people how can use the simulator. If you later on you want to go change the structure of your neural net, via my gas, this is how it goes. It's different layers, for example, if you want to do it. But in the beginning, just get people to go run the simulator.
Right. I guess we covered that last week. I mean, driving and getting the simulator up. I didn't really, I didn't put any details on here in terms of the manage or the my config. What you need to do, it's really in the docs, but yeah, you're right. In my config, there's some parameters you set up, and you once you set those up, it will fire it. I think what I've seen in the discussions and people not really understanding if they put the path in there, what that means. And so I think maybe to clear up that confusion, for me, the important piece is understanding that when you have the sim path in there, that is a path to an executable that gets called when you call manage.py. And so that executable has to be on your PC. It's got to be running on your PC, and it's got to be accessible. So you have to give it the right path. And you have to give it the path to the executable, not a folder. And I think in Mac, it was confusing because people were giving it a path to the .app folder, and you have to dig a couple more levels into there to get the right executable. So those are the beginner things that I think we need to talk about and have clear for the folks. So if you're going to have a path, put it in there and give the right path. Now, if you want to run a remote server or you want to fire up the simulator yourself, then you need to understand that as well. And to do that is don't give it the path, because if you give it the path, it will automatically try to fire up that executable. So now you don't give it a path, and now you have to give it the host on where the server resides. And if it's still on your host PC, then you have to give it your loopback host or the actual IP address of your PC so that it will send the packets correctly. So to me, those are the points I was thinking of highlighting for people that are just starting off with this. So if there's several configurations. You can have it on your own PC, and you can download the executable, point to the executable, and you're off and running. But now every time you start up manage.py, if you don't quit out of the simulator, you're going to fire up another copy of the simulator. So I've heard, you can have multiple copies of the simulator running if you do that. So that's probably not what you want. So if you want to just start it once and then fire up manage.py a bunch of times and have it connect to your simulator, then I would connect it the manual way, start it the simulator manually. So that would be kind of the second flow. If you're using the executable to get started by manage.py, that's kind of flow one. But then you get this multiple simulator problem if you're not quitting out of it each time. An alternative flow to that is to start it up manually. And to start it up manually, the configuration is a little bit different. You don't give it a path because, in this case, it doesn't have to be on your PC. It could be remote, but it could be on your PC. So that's also the confusing part. So if I now go to, this is the other configuration I talked about, is you could fire up the simulator in the configuration, you say it's remote, right? So the path is remote, and you give it a host address, but that address is actually really running on your PC. So it's another configuration. It's a way of running the simulator all on the same host. but it's just another way of firing up the simulator. You do it manually instead of automatically. So that's the two methods. And then the third method associated with this is to actually have this on a different host. So you're running it on a different PC. And so when you do that, the host address that you give it is the IP address of that. And it can be anywhere on the internet, and it just must be accessible. And so this is the way the virtual race is going to be run. The remote is, trainmydonkey.com is the IP address of that remote. And that's how you're going to connect into TON's sim server when we run the race.
Hey, Paul,
And so,
could
yes.
I quickly share my screen and I'll just show people my config very, very quickly, what the files look like and stuff like that?
Yeah, sure.
Okay, let me do that.
I think if I stop share, I don't have to stop share, but I think it'll.
Okay.
Yeah, it's at the bottom. Do you know where it is?
Let me see here, optimize. Okay, here we go. Okay, I'll share that. Okay, let me know if you can see my screen.
Yep, I see it. I see a
Okay, so
terminal.
this is my home directory, right? And this file here is I'm on Linux, but it's similar in other systems. I've downloaded, this is the simulator that I downloaded. I unzipped it, and the simulator's in here now, in this folder. So if I go into that folder, and this is the actual executable, right? So that's the application that is the simulator. So now if I go into my car folder, which I call SimCar3, right? And I look at my config folder, and just quickly, you can see that there's my config and manage.py. These are the things that we're calling that to drive and train. And this is our configuration. So if we look at that, and I head down a little bit to where we define Donkey Gym.
Right.
So to run the gym,
Yep.
you uncomment this stuff, and you said Donkey Gym to true. This is the default. This is the track we're going to race on. I've left gym config is just a way to make your car look differently. I've left it as the default. I shouldn't have even have uncommented that, but so that's the default. The important parts are where you install the simulator. So in mine, we can see it's in my home directory, it's in that folder, and it's that executable, right? So it's the full Pathia executable, like Paul said. And then when I'm running locally, my host is localhost 127.0.0. Now, when I'm going to race, what I do is I simply go into here and, and I comment this out. I comment out those two lines. Oh, sorry. I'll comment out these two lines and then uncomment the lines below, which set it up for the race simulator. So I'll say, now Donkey Sim Path is this constant called remote. So it's saying, hey, you're not gonna fire up. Basically, what this is telling it is, you're not gonna fire up an application anymore. You're just gonna connect to this host. And Ton set up this domain, trainmydonkey.com. So we all have a standard place to go. So he's hosting that domain, and he runs the server on that domain. So when we're racing, we'll use this config, and we'll be talking to the shared server. When you're running the sim yourself, you'll be using this config. So you're launching it locally. Is that helpful?
Yeah, that's great, Ed.
Yeah.
Yeah, and then, just to add to what Ed's saying, I guess I should share my screen now, is that the host that you point to, he pointed to Ton's server, but you could point to, for example, your local your local network and point to another laptop, for example, right? You just need the IP address of it. And you know, I've set up very similar to what Ton's doing. You could set up a server and have a domain that goes to that server, and so you could have a server as well. So it's just, you know, it's nothing specific that Ton's done that makes it that you have to go to his server. The configuration is such that you could set up any server. Like, you know, I saw the Japan folks had a race just yesterday or early yesterday in Eastern time where they were racing. So they've set up their own server. I actually also have set up a server as well with the Twitch feed, you know, after discussing with Ton. So those, you know, in terms of how to set that up, it's just, you know, maybe it's, when I talk about it, it just seems fairly straightforward. But if you're not familiar with domains, IP addresses, servers, clients, and things like that, it, you know, to Jack's point, it just makes people's eyes gloss over. But to, you know, if you do want to go that way and set up your own server, it is pretty straightforward. You just need IP address of where the simulator is running and configure that in my config, and then set your host.
Just to clarify, Paul,
remote.
you do not have to set your own separate server, right? You can run that on your, if you're starting, you can run all that in a computer. And that's what Paul was showing before, and it says local, and then it has the IP address that's basically a point to a local machine. What Paul
Yep, I understood.
now, what he's saying now is, if you want to have a server and then let people run on your server, because then you have to watch multiple racers, right, anywhere in the world, and you do that route. But for starting and to train and to do your own stuff, then to be ready for the race, you can run all in your local machine. Does that make sense?
Yeah, understood. Like what we said, configuration 1, everything on the local machine, go for it. That's, I mean, that's the way to go. If that's the simplest method, for sure. I know on my machine, it makes my laptop fan run constantly when I have everything running. So I push it to another machine. That's just another reason that I want. I guess I have an old laptop, and it just doesn't run well everything together. So for me, I like having just pushing it off to, I have another old PC that I push the server to. So understood. Like, you know, I'm just giving more details here to the folks. If you don't need to run these configurations, then and it works on your PC, then yeah, I would just run everything on one, because it is the simplest. The last thing that I wanted to highlight here is this is not restricted to Donkey Car software. There are actually people that have rolled their own custom client, and all you need for that, it's just actually similar to the workflow they would have. So if you have a jet racer, there's other people that just have their own model for inferencing and training. They don't use the Donkey Car software. All you need for your custom client is to be able to take these input images, send them to your model, and predict your steering and throttle. And then you send that steering and throttle to the sim server. And there's an API that's already defined for that Ton set up. And so if you want to run your own custom client, there's some example code. You don't have to run the Donkey Car software, but if you do the Gym Donkey Car, there's a test client that already uses the Gym Donkey Car package. So I think this is like researchers that were doing this reinforcement learning already were using some environment like this. If you want to do standalone with no dependency on any Donkey Car software, Ton actually created a new gist here where he's pulled in the critical parts of that were in the environment Donkey Car, or the Gym Donkey Car environment, and pulled it standalone. So now you can run this Python script independent of any Donkey software. And if you want to look at the API reference, I have a link to it here. So Ton's added that as well to the simulator code. So those are people that if you want to, if you're running, for example, Jet Racer and you want to take the Jet Racer model, if you take this client, you could probably plug it into the model that you have, feed it the data. All right, and I think, oh yeah, I have a couple more slides just comparing the hardware. So there, how does this work with the hardware? So here it's just the hardware is the camera. It's feeding images to Pi, and Pi is sending it steering and throttle. And so that's being replaced by is this flow here where actually this code here, when I looked at this Donkey Car software environment is actually the same code that's running on this Raspberry Pi. But it's really running, right now it's running on your laptop. But it's taking images from your simulator, going to the Donkey Car, doing the prediction and sending out the steering and the throttle and sending it out to the simulator. So this is basically how we're replacing the camera input feed and then the steering throttle output from the model and feeding it into the simulator. And then the simulator, obviously it updates the image and then passes the updated image back. And that's how we have our loop, similar to the loop with the real images. And then this is just an example. I just showed a real image that comes from one of my training images. And then this is the image from the simulator. They're exactly the same size. They're 160 by 120. I think that's right, the dimensions. But the simulator is set up such that the image that it's expecting would be the same as from the real hardware. So actually that just reminds me, if you're rolling your own test client, you do have to be aware of the images being sent from the simulator. And Ton has set up some camera parameters. So you can go in there and set up the camera parameters, a field of view, and also kind of the location of the camera. So that hopefully it makes it easier for people to plug in these other models with perhaps a different camera perspective. So that's that. And then I just have, that's not too interesting. It's the simulator, the main menu, and this is a new view that Ton has added as well for the overhead. And that's my last slide. Not too bad, half an hour over. All right.
We're not paying you for the extra half hour. I'm just telling you.
What's that?
We're not going to pay you for the extra half hour.
Yeah, okay. Thanks.
Hey, Paul.
So, hopefully people found that useful and interesting. If there are questions, I don't know, there seems to be tons of chats in there. I don't know, Alex, if there's questions people were asking that, I don't know if I've gone over them just from the topics, or maybe we can follow up after.
I think most of them were answered. One question is if you can show the my config.
Yes, okay.
And then also quickly, if you guys don't mind, we're all learning how to do this stuff virtually. And so, yeah, again, thanks to everybody who made this possible, including Paul, Ed, Reiner, Nick. But any feedback you guys have, please submit it in the form. It would be very useful on how to make these workshops better, and no such thing as bad feedback. So please type away.
All right, I'm trying to, yeah, okay. I'm just trying to organize my window here so it looks well.
The link to the feedback form is in the chat.
I would like to start with one question. Sorry for spoiling your server with tons of crashed cars, Paul.
Oh.
It's nearly the first time I'm trying that. And can you give us a hint of what is different in setting the parameters, for example, for latency? Something like, I said something like 220 milliseconds, giving AI throttle. And see whether that's really, what is the difference? Because it seems a huge difference between running the model that works quite well on my local server compared to running it, for example, on your server. Any hints of what are the traps to avoid?
Yeah, excellent question, Reiner. So the environment that we're going to be running in when we're in the races with a remote server, and what happens when comparing this, where you're all in the same PC, to the remote server, it's still actually using TCP/IP here, but your ping to this server and this client is really short. Whereas here it can be upwards to 200 or something milliseconds. So one of the things I would do is I would ping the server. So ping my server and then tell me what the round trip is, right? And so when I tried to run on Ton's server, it was 100 milliseconds. What that means is your inference of your images and your steering and throttle that you're passing back has a delay in it. And that can have a material impact in terms of how well you are responding to the images you see and the data that the control signals that you're sending back to your model. So
yeah, 100 milliseconds is, 20 frames a second is 50 milliseconds. That's 2 frames. So you're actually predicting 2 frames, behind where you are on the track.
Right. Good point, Ed. I didn't even think of it that way, but that's a really good point. And
now, actually, there's someone, if you look on the boards, and I believe it's Nazy, has written a utility to actually handle this.
Excellent. Yeah, there
so
is, and
it'll rejigger your tub and align the images given. Essentially, you're predicting the future, then, right? So you align the images with your data in a different way, and so it's seeing the delayed frame when it trains.
right. Yeah, I can't wrap my head around. I always get confused which one is ahead of the other. But yeah, it would be, so the image that you see, and then by the time you send that control to the server, it is now 200 milliseconds or whatever your delay is. It's later. So now it's actually reacting to an image that is, yeah, 200 milliseconds too late. So Reiner, the configuration that you talked about, that latency, Ton put that in exactly to emulate that delay. So if you know what the ping delay is between your remote and your PC laptop, I would that's what you put in as your latency. And therefore, when you're driving and you're using the image to drive, then you're also kind of compensating for that. But you have to use the FPV image to drive. And that's a bit tricky. The other thing that Ed mentioned is there's a utility that Nazy wrote that will take your data and offset your control by that amount of delay. And I think the default's like 100 milliseconds. So it will take that and it'll take the control messages and send them. It will look at an image to, your image 200 milliseconds in the future and send the control for that image. And so and Nazy's model is super fast. He's like 16 seconds a lap. That's crazy. and he's running fine on Ton's on Ton's server. I saw it during the week he was running. It's pretty crazy.
So to make that clear, the latency should always be set according to the host you're connecting to. So if it's a local host, you put in a very small latency, and if you're connecting to Ton server, something like 100 millisecond. For your server, I just pinged it. It's just slightly above 200 milliseconds. So that would be the correct value setting there, right?
Yeah, like that's if you want to test, like you can't test on Ton's server if it's offline, then you can mimic that environment by putting that latency in there.
Okay. Thank you.
You're welcome. That's a really good question, and I think and you know, that's probably another piece of really understanding your environment here. And when you go remote, and I think people, that's why Ton is putting a server up and having people test, because I have a model that works perfectly in my environment, and I put it on Ton's thing, and it doesn't drive at all. Like, it's all over the map. And the reason for that is this latency. And it becomes critical, like when you're up to 200 milliseconds. And the other thing I found too is sometimes there's a glitch and your frames per second will go down to like 5 or 6. And your car has lost so many frames at that point, you'll go off the track. And if your model is not robust, it won't find the track again. So those are things definitely you'll learn as you are testing and training your model in the simulated environment.
Okay. Is there a way to remove all the wrongly spawned models on the server? Because I think now I spawned the 10th server, the 10th client on your server. Is there a erase all clients?
How do you kill the client? As soon as you kill the client, it erases it from the server.
Yeah, on Control C. But
That
have
should kill the
have
client.
a look at your Twitch TV. Then you see the mess.
Okay. Yeah, I'll have to look at that after, Reiner. But yeah, that's.
Yeah.
I thought when I control C for mine, it gets rid of that, and so you spawn, your car will disappear and then it will spawn again. Okay. So let me actually, there was a question about, can I see myconfig.py? Was there a specific section that people wanted to, or they just want to see it in general? So this is I don't know which one this is. So it could be one I just kind of mocked up. But in here you can see in myconfig.py, the default one, everything's commented out. So if you want a value, you have to comment, remove these comments. But this is it here. You just go through this, and this is all the different values. The hardware that exists on your donkey car, you have to uncomment the line. And of course, it's got to match with the hardware that you have.
There's another question that came in on how to connect a different machine. So I think maybe, please correct me, Andrew K, if I'm wrong, but I think that goes back to what Ed showed in terms of how to connect to a server versus running on your local machine.
Yeah, it does. It is what Ed showed. Just to answer the question specifically, I will go to that point on my config file here. Oh, sorry, I have to, how do I, whoops, okay. I want to find.
So again, the file that is being used is myconfig.py, and this is where all the modifications are being made. And the myconfig.py file lives in where you downloaded the gym environment, right? Like, so my sim, for example, in Paul's case.
Yep. Yeah, so if I go back to my presentation here, if I go back to the way back when we talked about car software. So when you do the donkey create car command and you specify a path, this path is your donkey car folder. In that folder will be your manage.py, and it will also contain your myconfig.py. So just go to your folder that you created for this car. I call it the car folder. I'm not sure what the right terminology is, but go to your car folder, and in there you'll have manage.py, and this is where you do your manage.py and your drive command and all that.
So it's
So
not
that-
in your my sim folder?
It is. When I create my car, the path that I called it was my sim. So my car folder is called my sim.
Okay.
So when I did the create car command, I typed in donkey create car -- path dot / my sim. I like my car folder to live in that directory, in the donkey car or Jim donkey car directory. I don't put it in my home directory, but the instructions say to put it in your home directory. So that path that I'm creating the donkey car folder in, I called my sim. That's what I call my folder. You can call it whatever you want. In the instructions, I think they call it my car. People can call it sim car. It's just whatever you call this path, that is your donkey car folder. And then once you have that, then in there, that's where you do the commands to edit your myconfig file. And that's where, if you go to your car folder, in that car folder, so here's my folder directory here. So this is my sim folder here. This is where my config file is. So this is my car folder right here, my sim. And my config file is right here. I don't know if this is a specific one I'm editing, but this is the one you would edit. And to specify, this is exactly what Ed showed. Search for Donkey Jim, and you have to go to that section, and this is the parameters you have to change, configuration. And so here you set it to true if you want to run the simulator. You set this path to the actual path to your executable. If you want this command to invoke your executable, you put the path in there. If you want to run the simulator yourself, you can set it to remote, and then you start the simulator yourself. And then you would give, if it's remote, you have to give it the IP address. So here I give it the IP address of the local loopback. So yeah, I'm actually starting the simulator myself. So now the question is, how do I point to a different server? You would now take this and put in the IP address of that different server. Or you could also, as this example shows, you could put in the domain. So if you, in this case, this is Ton's server, you would put simhost and you would put the domain of the server. Is that still I don't know if they want to try that and make sure it works, but that's how you would set that up.
Well, is your server up and running? Can you give us either the IP address or any domain in the main register so we can play a little bit and see if it works for everybody?
Yeah, just a sec. Yeah, that'd be cool. Okay, so here's the Twitch feed, and that's one of the things I was trying to do. The domain of that is Donkey Sim, and let me put it in the chat. Or maybe Reiner. Reiner, can you put it in the chat? I'm going to try to go to my server and reset it. Oh, here, race, exit. I'll exit and go back in. Okay. Okay, so I'm not sure if Reiner's still around. It's pretty late, so let me go to the chat.
I'm around, but not so fast on typing on an iPad.
Oh yeah, okay. Like I can't
No
find.
copy pasting.
I can't even find my chat screen. Where is
Someone
it?
is
It's
going
up
to
here
bed
somewhere.
late today, huh?
Chat. There it is. Okay, here we go. It's donkeysim.paje.ca. I can't type either. Okay, that should be it to the server, and then it should be running now, right? Let me see if my, okay. Oh, you know what? My thing crashed, so maybe it crashed it crashed that as well. Okay, I'm gonna try to run a model too. So folks, if you want to,
So did you post your domain there?
I
On
did.
chat?
It's in the chat. Did I post it to everyone? Oh no, I just posted it to one person. That's not very
Right.
good. Okay,
Okay.
sorry. Everyone. Okay, there. Okay, so there's mine, and then now I have to. Oh, you know what, Reiner? Did you start it running? Like you have to change your model so that it goes to autopilot mode. So here, I have to change mine
Yeah.
so it runs
Yes,
autopilot.
I did that.
Okay, so there, mine's running now.
Okay.
Okay, there, mine's off. So everyone should go, and you guys are all parked at the starting line. We're all gonna crash.
I've got a car in front of me.
Oh yeah.
I haven't trained overtaking yet.
There we go. Oh, you know what? Oh, it's too bad. This one's on a Linux laptop, but the new server that Ton has, or the new simulator, has an overhead view, which is really cool. All right. So that's that's the Twitch feed. So hopefully people can see that. That's the Twitch feed right there. Where's the chat again? Oh, here it is. Oh, I think once it crashes, it really. Oh, sorry, I didn't type that right. Okay.
Trying to push them away.
Here, I'll reset it again. Let me exit. I'll exit and then we can.
Okay.
Okay, I exit. Now we'll you can restart again. Okay, there. There's a 10-second delay. Okay, so I think what I'll do. This is probably not too interesting on a recording. So I'll stop the recording and yeah, and then we'll point it to, the recording to other people. But I will stop the recording now.